speaker today to get us kicked off is Dr. John Fulton from Ohio State University Extension. And his topic today is using precision agriculture and machinery to enhance production and reduce environmental risks.
All right, test. That sound okay for everyone? All right, we can hear if we turn it too loud. But no, thanks Jessica for that. And I guess Randall asked me just to bring some comment to some of the technology. And so I want to break this into kind of three parts. I'm going to talk a little bit about some of the technology. I'm not going to cover the full breadth of technology out there, but also going to get to the middle and talk about, in very generalized terms, some of the science and such around variable rate fertilizer and how it can help us in this arena of environmental risk, environmental concerns. And then I'm going to just drop off at the end and talk a little bit about where I see some of the adoption levels here for the state. So.
Let's give us a minute.
Sorry, 1 second.
Yeah, keep going, eh? So, but anyways, just to put us all on the same page, I see, or when I talk about precision nutrient management, as we think about it today, what I think about and what I'm going to talk about here in my brief comments is we're taking some kind of soil sampling scheme. A lot of times we talk about grid or zones, and then we're going to bring that back, and through a process, we're going to convert that to a prescription map, as you see on the screen there. What I would say, at least in the state of Ohio, with a lot of our folks that are delivering these type of prescriptions, they're also adding yield maps in today as a means in between sampling schemes as a means of removal. And so that's part of the equation as well, as removal maps are inserted in, and then in a lot of cases, or at least we see more growers going to kind of a every other year type application, okay? So we've got soil precision sampling, yield removal maps from the yield maps themselves we're creating in prescriptions, then ultimately, and what I typically work in is variable rate technology. Okay, and to me, that's the execution part. And for some cases, I would argue that if not done properly, everything done prior to that is very not meaningful. But we got to get the execution right, because it does matter. So I do think that our nutrient toolbox today, both in terms of implements and equipment availability, but also technology availability to growers, or consultants providing recommendations to growers is pretty wide today. There is a lot of tools. In fact, when we go back and look at just subsurface / injection systems out there, we can count somewhat over 50 different types of tools out there. So it's a pretty wide swath of what's available, but I always want to advocate and get people thinking is, are you selecting the right tool set for your operation to execute and support your precision nutrient management strategy, okay? That's very important. So I'm just not picking a tool because someone else is using it, but I'm picking it for the right reasons and accomplishing the right things around my precision nutrient management. It's a very systems approach. We'll talk a little bit about ROI in a little bit. But I always like to remind people, too, at least in the state of Ohio, I think, and based on some of our findings, that precision nutrient management, both in the case of PK and lime, but also even nitrogen, that in Ohio we have a lot of opportunity, especially at the farmer level, not only for return on ROI, but this thing about reducing environmental risk too. But the fact is we got a highly variable soils, both in terms of texture. In this case, you can even see organic matter differences out there. And so being able to characterize that and implement strategies, is going to be the best thing in the approach. The question is, can I afford to do some of the approaches that are being offered? And so there's an economy to this as well, and I want to understand that. But I do think there's a lot of opportunity to implement variable rate fertilizer strategies in the state of Ohio. If we take that to some of the I states, they don't have this kind of variability that we're working with here in the state of Ohio. Okay, so they may not see some of the benefits like what we can in our conditions. So we talk about machines, we talk about agronomy, bringing agronomy, okay, but ultimately it's about doing agronomy better, but today we add the environmental component in. So here's some things that have come to market that is more prevalent. Again, very generalized. This is a very common way to deliver fertilizers. You're seeing actually in this picture of the spreader delivering urea is a mid-season kind of application of urea. But for most of these applicators at the retailers and co-ops, we have the opportunity to do dual bin or multi-bin, up to 4 to 6, depending on some. But dual bin is pretty popular. My point in that is, if you start to see some of the research that we're starting to publish, the dual bin approach does a couple things. Number one, it does a better job of metering the product versus me blending it and then potentially having some segregation that can happen with that blended product. So we do a better job of metering and distributing that. But we're seeing that in not only spinner spreaders, but we're also seeing it in some of our newer kind of injection machines, our subsurface applicators, where they are dual bin. I can put Dapper MAP in one bin, if I can put potash in another bin. Again, when we look at prescriptions, we know on a field, if I go back to the prior picture, that my P prescription is not going to be the same as my K prescription in terms of magnitude. So the ability to separate those out and independently meter is going to allow us to execute better to meet those site-specific needs of the soil as we've measured through our soil sampling. So dual bin is something that's come to market, and a majority of these machines, as you see, have some kind of display or rate control system on there. They can execute variable rate prescriptions. But the other thing, and I want to show you some of the newer technology that's finally come to the U.S. that have been in Europe for a while, but swath control. So you can actually turn sections on and off, automatically versus the operator making a decision. So I can cover a grass waterway. I can go through the grass waterway today, and on these newer machines, it will actually shut it off if it's pre-mapped into the controller. And that's a real benefit, okay, to us. So we keep the fertilizer out of those areas that we don't want it, or we don't double apply in areas that's already previously been applied with some of that. And I'll show that in a second. But these new displays, and we see these also not only in applicators, but in the tractors today, but any of these displays are really, to me, one of the best investments that farmers can make, okay? Because it does a couple things. Number one, it enables me to do some things on my farm that I maybe couldn't have done, but the feedback to the operator during the application ensures that the machine is meeting maximum performance. That if something goes wrong, I know it then and I can make an adjustment. Some of the older model type displays would not give us that kind of feedback. But for me, when we look at these displays, it's really been able to identify issues that we may have in the field and be able to correct them then versus going through a day's versus work and finding out later there's something wrong with the machine. I want to highlight too that the machines, and this is basically off an applicator, okay, and don't worry about the percentages on the left side, but basically what you're seeing is, can the machines today execute a prescription? So when I go across the field and I go from a 0, let's say, to a 200 pounds per acre requirement on the machine, how quick can it change? Okay, now I move to a new area of the prescription, in the case on the right there, for example, it requires 300 and jumps to 300. Can the machine respond quickly? And what I would tell you in most cases today, across the board with what we call PWM or pulse width modulated valves, what you see is on the orange is the actual machine response. The dashed line there is what's the prescriptions feeding into the machine, and you see it map very quickly. So what we're saying is, if I showed you some data from about 10 years ago, some of the technology would take 2-3 seconds to make a rate change, but today's technology, I wouldn't say it's instant, but it's very quick. And so we've overcome some of the limitations, which gives us the capacity to execute a prescription like that on the right very accurately with some of these newer machines out there, both on the spreaders, but also some of the metering systems that we see on like the subsurface application equipment we've measured. So that's encouragement that we can put a prescription in and execute it very accurately out there. Here's some new things. This is courtesy of New Leader or Highway Equipment out of Iowa. Basically now on a spreader, up until last year, basically a spinner spreader would have to shut the complete conveyor off. So I've shut the full width off or on. It was a full width. It's kind of like having a planner. I can only manage to the planner width, but today we can almost get, well, in most cases we can get technology to go But in this case, new leader came out with this and started to present it last year. But the ability to have automatic section control across the applicator, you see portions of the applicator on the right side being turned off, where on the left side it's still running. But very simply, what they have done is they're managing each of the spinners independently, their speed, and they're moving the spinners relative to the flow of material on there to meet this. And not only does it shut on and off in sections, but what you see there is their new applicator, actually that spread width is broken into 12 sections. So all of a sudden we take a full width applicator going 90 foot, what they can now do is split that into 12 individual sections with this new technology. So we're better managing the spreader versus trying to throw 90 foot and not being able to, if I needed to cover that full area, I would have to probably cover the full grass waterway in order to effectively get it applied. Okay, so exciting new technology on the spreader front, and I expect a couple more companies to begin to present that on their machines here in the coming years as well. So we have automatic section control. What does that mean? This is my best presentation of that. What you see on the top is basically an applicator full width. It's going out, and the operator's having to make the decision at the end of the row in the headlands and the point rows to turn the machine on and off. Okay, the blue is the double applied areas, red is skips, and in the bottom there you basically see section control, multi-section control being used. Same machine, just putting it on the machine. What you see, there's basically very small, very negligible areas that get double applied in areas, making sure we minimize the red. So we're doing a much better effective job of getting the fertilizer applied in this case. So that's one technology. Again, the other thing that's come, and I just pointed out, this is again from new leader. They've got technology now that we know when we've made the first pass around the field, for example, on a spreader, we were always light on the outside, right? Majority of the material from a spreader is in the center, then it goes outward. What they now can do is basically speed up and manage the one side out on the outside and put a uniform out to pretty much the edge now to uniformly apply out on the edge or in those headland rows now with this technology. So we get section control, you get border spreading now on these spreaders, and it really opens up the ability to more uniformly get our fertilizer applied, okay, and overcome some of the limitations we had up until the point these type technologies came to the front. So just to remind everyone again, we've got a lot of technology and we're going to hear more about that I think this morning about injection or subsurface placement. This is one example. Again, I've got my P prescription on the left, the K prescription on the right. I can load the front with potash, the back with MAP, and I can go out and independently, not only strip, but I can independently meter those two products across the field in accordance to what our prescription map requires versus having one big bin, I blend it up, and I have to compromise that variable rate map that we have underneath there in order to achieve what, minimum requirements. I got to pick P or K in some cases to be my minimum. So, and this one also has section control again, and I can do variable rates. So again, a lot of this technology is becoming embedded in these machines. It's upon the farmer or those providing the services to take an opportunity and present that and see the benefits. So anyways, I just wanted to kind of highlight we're seeing more. For those of you that aren't in Ohio, we're coming back and we're placing more fertilizer with the planter today. In the case what you see here, it's just an example that you got a 2x2. You can't see the tank on the back, but we also have furrow or in-furrow technology on here. So again, our ability is growing to get timing stretched out to deliver fertilizer, P, K, and N, a lot of times we're talking about, and planters are becoming more common, and technology is being built. Probably one of the hottest themes that I'm not going to talk about today is this 2x2x2, but the opportunity to place with the planter is only growing, it seems like, in the state of Ohio. So, a couple of comments before I start talking about benefits. This is one example. This is from Precision Planting. This is what they call their smart firmer. I would say this would be their first year of really getting it out to growers and utilizing it. My point here is, as you look at that, is the opportunity to measure soil parameters on the go, and there is this opportunity down the road that I might be able to control some things on the planter, okay, possibly even fertilizer, in accordance to what the feedback is from these type sensors. So you got stuff on the planter that's starting to collect a lot more information or data from the soil during planting. What I'll tell you is there's a couple companies that we're starting to work with on sensors, specifically P and N or nitrate sensors. I'm not here to say they're perfected by any means, but what I am trying to get you to think about here is we're getting more and more sensors. We're going to get more and more data from the field that may help us improve some of our P and N decisions. Okay, so we've got some new things coming to market as it relates to sensors that are going to be providing us some new data sets or feedback to help us in this realm of precision nutrient management. Benefits, I'm going to talk about 3 real quick and then I'll be done. First of all, what we know and we've measured for growers that have adopted a precision nutrient management. That is a precision soil sampling strategy, zone or grid typically we'll talk about, followed by a variable rate application based on that over time. I want to highlight over time. Okay, this could be time to get some things corrected. So I'm not saying the savings come immediately, but as we look about it over time, there's a 7% opportunity on average that we did in this to reduce the amount of fertilizer applied. Okay, but it in some cases takes 8 to 10 years to see and see those savings, but it's on average we've seen a 7% reduction, okay, of fertilizer used for those that have implemented precision nutrient management strategies. So there's a real opportunity to the grower for that. We couple that and we really look at the return on investment, okay, and these are a couple of projects that I'm kind of pulling this from, what it means to the grower if they're implementing a variable rate fertilizer strategy. Primarily we're talking about P, K, and lime in this case on this particular slide. What we're going to see from a net return or return on investment. That means buying the technology. That means buying the services potentially, build the maps and collect the samples and everything. At the end of the day, these are just some average numbers. This would be about $1.50 to $3 an acre advantage for those using precision nutrient management. So a couple benefits there. Finally, with this type of strategy, we hear this a lot. It's probably not new to everyone, but our ability to implement these strategies and go out, we're better tailoring our fertilizer plan to what the soil sampling or what requirements are. What I would tell you is, at least in the 2 states that I've studied some of the research in, that show that there is a reduction with these strategies to nutrient loading. Okay, and so there's a value both to the farmer, and I showed this in a prior slide, return on investment, but at the same time, the strategies provide an environmental reduction or risk to not only the growers, but for what the public's requesting out of this. So there is a direct, and we've seen that reduction percentages in some of the other states that have posted or brought research forward around these type strategies. So just the last thing, and then I'm done. I just want to highlight we know from a survey here that 60% of the area or acres in the state of Ohio have or is getting variable rate applied P and K. Just to highlight that adoption and the progressiveness in farmers in Ohio is high in this area. 2 other things I just want people to think about that we measured. Over 80% of the farmers, and I bet if we did a poll here today and we all pull out our smartphones or iPads, that over 80% of the farmers today, regardless of age, are carrying a smartphone. And if you look closely there, majority of that is done for communication purposes, but what we do see is the ability to have information at their fingertips in this realm of nutrient management, okay, because of the use of smartphones. Lastly, and we just did this in a survey last year, what we found is that growers that have precision technology, okay, and let me describe to you who we asked this question to, but growers have been using precision technologies, plus have been doing variable rate fertilizer, probably variable rate seeding, 84% of those growers are doing on-farm research with a primary emphasis on nutrient decisions, which is encouraging because we know nutrient management is local and is also embedded in the farm operation or the system that's chosen to manage the crops. But the highlight here is that 84% of the growers that have precision technology and have been doing variable rate type strategies are doing on-farm research, which is an encouragement to me, especially when we see that they're doing a lot of nutrient type work, that they're being able to understand and tailor their programs not only for themselves, but I believe it also goes back to the prior slide of being environmental stewards. So with that, just three things that I kind of covered. I think variable rate fertilizer adoption is still growing. The trends that we see here in Ohio suggest that, even with the relaxed markets, crop markets. The ability to match soil fertility to subfield requirements, again, provides more tangible benefits not only to growers, but it also addresses and provides sound environmental stewardship for the grower. So anyways, there's quite a bit of benefits. And so with that, Jessica, I guess if we got a couple questions or comments, pushback, whatever, we can take that. Quiet crowd here this morning. It was a good night. That's true, right? All right. Thank you for letting me come today. So.